Humans are very visual creatures. We take in most of the information we learn through our eyes. Okay? Other animals use the more sense of smell or hearing, but we use our eyes a lot. Same with science. We pick up a lot of our information with light and other forms of electromagnetic radiation. Okay, so today I want to talk just a little bit about the spectral lines, spectrum and spectral lines. Okay. So what I have here is just, it's called a gas discharge tube. So all it is just two electrodes, so you can connect it to electricity, and then there's some sort of gas in here. Okay, so this could be hydrogen, helium, just fill it with the gas. So here I have neon. You've probably heard of neon lights before, of course. Fluorescent lights use the same principle. If I turn it on, let electricity run through it, of course, it lights up. Okay? So what exactly is going on when it lights up? Well, think back to your chemistry days in middle school, maybe. All right, so here we got a simple atom. Let's say it's hydrogen. Okay, the most plentiful atom in our universe that we know of. Okay, it's only got one proton, which of course is in the nucleus, and it's got one electron. Okay, it could have a neutron, but most atoms don't, so it's pretty simple. Okay, so here's what happens. When hydrogen gets excited, or any gas gets excited, okay, it's the electrons that get really juiced up. Okay, and when they do that, they jump up. They call these orbitals are energy levels. They can jump up one level, or they can jump up a couple levels. Okay, so they absorb that energy. And now you guys already know, law of conservation of energy, okay, you can't make it or destroy it if you change forms, but if you absorb energy, you're going to have to release the same amount. Okay, so what happens is electrons get kicked up these energy levels, and then when they fall back down, they give off light. And they give it off of a certain, I'm going to hear, wavelength of light, or a certain color. Okay? And it turns out that every atom has their own, quote, fingerprint, or own pattern of wavelengths. Okay, so for hydrogen, it looks something like this. Okay, here's Roy G. Biv backwards. It gives off a bright red line, so a red wavelength. It gives off a blue, and it gives off a purple. Maybe a couple purples, but that is its characteristic spectral line. So just like a fingerprint, if you look at a lit object like a star or the sun to star, they look up with spectroscopes, which are basically diffraction gratings, which are really sophisticated. You've probably looked through them before, maybe in your science classes. But this will separate the lights out. You can see those lines there. Okay. But if you do that, you look up and you see this pattern. That tells you that that star has hydrogen in it. Okay. So that's one of the key methods by which they discover what elements are in what stars and how much of it by how intense those lines are. One other thing with this, when they look at galaxies, they notice that every galaxy they look at is primarily hydrogen. Okay? They have other elements too, but primarily hydrogen. And then everywhere they look, you get this banding pattern, but it all shifts just a little bit that way. And we see that's red shifted, okay, which is to longer wavelengths, okay, which is going to be to lower frequency. Okay? And if you remember with sound, you remember if objects are moving closer together, okay, the frequency goes up and the wavelength goes down. But as it's moving away, then you go to longer wavelengths and lower frequencies. So this is the major piece of evidence which support that. Everything was at one time all compacted together. We call that the universal singularity. Okay, everything's and then about 12, 15 billion years ago, everything just exploded out. So everything is moving away from each other. So you have all these galaxies out here, spiral galaxies, moving all in different directions, all out. Okay? And of course, where's the center of the universe? Well, everything's expanding, so everywhere is the center, but it's kind of crazy to think about. But from here on Earth, okay, and we're of course in the Milky Way galaxy here. We're actually on an arm out here somewhere. No matter where we look, there, everything has hydrogen as a primary component, okay? And everything is redshifted, okay? So it's shifted towards longer wavelengths and lower frequencies, which means that it's moving away, okay? So that's the major piece of evidence supporting this Big Bang theory which occurred